Global oil demand has rebounded to 98 million BPD from 93 million BPD early this year.
2021 until 2022 global energy crisis is the most recent in a series of classical energy shortages experienced over the last 50 years.
Researchers at the U.S. Department of Energy National Renewable Energy Laboratory (NREL) create a solar cell with a record of 39.5% efficiency under 1 cent global illuminations.
By 2050, solar capacity will need to reach 1,600 GWAC to achieve a zero carbon grid with enhanced electrification of end use.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syafiqah binti Mohmmd Salimy.
Assalamualaikum warahmatullahi wabarakatuh. My name is HANIS SAHERA binti ZULKIFLI.
We are going to present on Experiment 1 and Experiment 4.
Experiment 1. Solar Energy Availability. Aims and Objectives. The aims of this experiment is to assess the solar irradiance amounts available and to assess the shading profile for a particular site. The objective for these experiments are to plot irradiance profile and to determine irradiance, and to assess shading profile and to determine irradiance at a site. Equipments. The equipments involved in this experiment are sun hat, sunglasses, compasses, solar pathfinder set, pathfinder chart, and solar remitter.
Procedure. Choose a location where there is partial shading and place the solar pathfinder. Set up the solar pathfinder set, pull the tripod leg and set up the tripod. Integrate the tripod with the base of solar pathfinder set. Set up the instrument, which consists of compass and level, on the base of solar pathfinder set. Align the compass and the level. Make sure the compass needle is in the right directions and the level bubble is in the center. Place the solar pathfinder chart on the solar pathfinder instrument. Place the dome of the solar pathfinder on the instrument and make sure the position is in the correct positions. Observe the shading profile. Sketch the trace of shading profile by using the pencil. Determine the irradiations available at the site and calculate the ratios of solar energy availability. Results and calculations. This is the result obtained from the experiment. The percentage shading is obtained from the trace of the shading profile on solar pathfinder chart which sketched during the experiment. The ASA value in the column number 4 and the value of H in column number 5 is obtained from the calculations as below. Since there are 3 raw data, we choose to demonstrate the first raw data, which is raw data 1. We choose the month of January, which the theoretical solar irradiation H value is 130 with percentage of shading is 18. The ASA value is obtained from the calculations above, which 100 minus percentage of shading and divided with hundreds. The ASA value obtained is 0.82. Next, the H experimental value is calculated by multiplying the ASA value with the H theoretical value, which the value obtained is 106.60 kilowatt amp negative 2. The annual solar irradiation is then calculated by total up all the H experimental value, and the value obtained is 1570.41 kilowatt amp negative 2 PA. The annual PSH available is calculated by dividing all the annual solar irradiations value with 1 kilowatt amp negative 2, and the value obtained is 1570.41 HPA. Discussion. Shading factor at the site must be assessed in order to determine the time-based availability of solar irradiations. It is the best to find an area with partial shading. This is crucial because shading will give significant impact on the models. In this experiment, we are aiming to assess and determine the solar irradiation's available amount based on the shading profile by using the solar pathfinder. The annual solar irradiations at the first site is 1570.41 kW M-2. The second site is 1552.77 kW M-2. Third site is 1762 kW M-2, and fourth site is 1654.46 kW M-2. The annual PSH available value at first site is 1070.41 HPA, second site is 1552.77 HPA, and third site is 1762 HPA, and the fourth site is 1654.46 HPA. The solar irradiation's value is commonly stated in megajoule due to its large value. However, the use of kilowatt hour is considered as a common practice. The conversion unit is 1 kilowatt equals to 3.6 megajoule. The annual solar irradiations at the second site is the lowest, followed by the first site and fourth site, where the annual solar irradiations at the third site is the highest. As larger shading profile is determined causes solar irradiations to be lower at the second site. Therefore, it is advised to find a site with partial shadings. During the experiment, there are few precaution steps that must be taken. First, we need to wear proper attire and PPE such as bright color long sleeve shirts, long trousers, hats, and sport shoes. This is because the experiment is conducted under the sunlight. Thus, prolonged exposure without proper attire or PPE may impose health risks such as heat stroke, dehydrated, sunburn, or even eye damage. Conclusions. As for the conclusions, the shading profile has been assessed and the amount of solar irradiation has been determined. Therefore, the objective is achieved. The amount of solar irradiations at the second site is the lowest, which is 1552.77 kW M-2. The amount of solar irradiations at the third site is the highest, which is 1762 kW M-2. The amount of solar irradiations is depending on the shading profile at the site, which higher the shading profile, lower the amount of solar irradiations value for the site. Experiment 4. Output of PV array configurations. Objective. Objective of this experiment is to measure the output of single PV module, to measure the output of PV module connected in series, and to measure the output of PV module connected in parallel. Equipments. The equipments used in this experiment is clamp meter, identical PV module, digital multimeter, personal protection equipment PPE such as safety hats, sunshades, sunglasses, and gloves, thermometer, pyranometer, and switchboards.
Procedure of experiment 4. This is the PV module used in this experiment. There are two units of identical PV module. The PV module was set at the place to take the sun directly when taking the measurement. The solar irradiance and the PV module temperature was measured at the beginning and at the end of the experiment. The PV module then will be connected to the switchboard using the respective terminal of cables according to the type of PV module connection. First one is single PV module. One unit of PV module was connected to the switchboard. The mode on the digital multimeter was set for measuring voltage. The clamp meter was set on connecting cable to ensure the switch was off. The switch was off when the clamp meter showed the reading close to 0. Next, we measure the POC and other. The radio set on the switchboard can be adjusted to measure the corresponding value of voltage and current at different value of resistance. Next is two module in series connection. To connect the two PV module in series connection, the negative terminal of first module will be connected to the positive terminal of switch port, while the positive terminal of the second PV module will be connected to the negative terminal of the switch port. And lastly, the positive terminal of first PV module was connected to the negative terminal of second PV module. By using the connection cable to connect the switchboard to the digital multimeter, the value of voltage and current for each of the PV modules was measured in order to find the value of voltage and current in the entire circuit. Two modules in parallel connection. For the PV module connected in parallel, an adapter was used in order to connect the two PV modules with the switchboard. The first adapter will be connected to the positive terminal of the two PV modules with negative terminal cable of switchboard. While the other adapter was connected to both negative terminal cable of the two PV module with positive terminal cable switchboard. The value of voltage was measured using the digital multimeter. The result was adjusted in order to measure the value of voltage with different value of resistance. This step was repeated in order to measure the value of current for each of the PV modules.
The results and data obtained from the experiment were shown in the tables below. Table 4.1 shows the datasheet for the PV module used with the type extra energy such as M6612PHV with the PMP 345 volts. The VOC of the PV module is 46.37 volts and ISC with 9.67 amperes. The experiment was done in the morning at the Mama Lapangan FNC near the college complex. For the measured data, the parameter solar irradiance with the PV module temperature was measured at the beginning and at the end of the experiment. The measured data for a single PV module shows VOC 42.76 volt and ISC at 5.30 amperes. The measured data for PV module connected in series shows VOC total of 85.20 volt and ISC 5.04 amperes, while the measured data for PV module in parallel connection shows VOC at 42.80 volt and ISC total at 10.82 amperes. The calculation involved in these experiments are the theoretical values of open circuit voltage VOC, theoretical value of short circuit current ISC, and percentage difference between the measured value and expected value of VOC and ISC. The VOC expected was calculated using this equation. The result shows the VOC expected for single PV module is 43.20 volts, PV module connected in series 85.27 volts, and PV module connected in parallel 42.68 volts. The short circuit current ISC expected was calculated by using these equations, and the ISC expected for single PV module is 4.93 amperes. The PV module connected in series is 4.75 amperes, and PV module in parallel connection shows ISC expected of 10.07 amperes. And the percentage difference can be calculated using these formulas. The percentage difference of VOC is 1.02% for single PV module, 0.08% for PV module in connected in series, and 0.28% for PV module connected in parallel. And the percentage difference of ISC for single PV module is 7.51%. PV module connected in series is 6.11%, while PV module connected in parallel, the percentage difference is 7.45%. In this experiment, the output was measured from a single PV module connected in series, and PV module connected in parallel. Polycrystalline PV module type used in this experiment is extra energy such as M6612P HV 345 volts. In this experiment, the time taken is approximately 4 minutes for each connection, with the solar irradiance and PV module temperature varies at the beginning and at the end of the experiment, which give different results of VOC and ISC expected and measured. The VOC expected of single PV module is 43.20 volts, while in series connections of PV modules, the VOC expected is 85.27 volts, which double from the reading of the VOC of single PV modules. This is because in the series connection, the open voltage reading was taken from the total of two different PV modules. While in parallel connections, the VOC expected is 42.68 volts, which is approximately close to the single VOC expected because in parallel connections, the voltage was same throughout the circuit of the PV module. While the ISC expected for the single PV module is 4.93 amperes, and in series connections of PV module is 4.75 ampere, which is approximately close with the single PV module because in series connections the current is the same throughout the PV modules, while the ISC expected for the PV module connected in parallel shows the reading 10.07 ampere, which greater than the singles and series connections because in parallel connection the current was calculated from the total of two unit PV modules. Percentage difference of expected value and measured value of VOC and ISC was present in this experiment, which was affected by the factor that influence the readings, which are the solar irradiance value and temperatures of the PV modules. For the conclusion, we can conclude that the objective in this experiment was achieved, since we have measured the output of a single PV module as well as PV module connected in series and parallel. And different connections of PV module shows different result of open circuit voltage and short circuit current. Small percentage difference between measured value and expected value are obtained, which means that the value of VOC and IOC is an approximately value.
That's all from us. Thank you.